It's Wednesday. Today we're doing 9-2 notes. We're going to talk about increasing, decreasing, and positive and negative intervals on a function. Okay, so where is a graph increasing, or where does it have an interval of increase? Well, increase is when it has a quote-unquote positive slope, which is not really true because slope means constant rate of change, so it's not really a slope, but it's where it's going up to the right. So where is this guy going up to the right? Well, it starts going up to the right here, and it goes up forever. So you're going to look at the x values. So the x value here is -1, and it is increasing, meaning it's going up to the right forever in that direction towards positive infinity. So that's either -1 to infinity, or you could just say x is greater than -1. And we're just talking about x values here. So when I'm looking at an x value, if I go from one x value to the next, is my y value increasing. So I'm going from here, my y value is negative something, going over here, y value is 0, then it's positive, whatever. Okay, decreasing is the exact opposite of that. Decreasing has a quote-unquote negative slope, but again, I can't have a slope because it's not constant, but it's when it's going down to the right. So if I'm going from left to right, that'll be this guy right here. And when does he stop going down? Well, you're always going to have an increase and a decrease changeover at the vertex. So there's that vocab word there. Still the same value as the previous one, but it's decreasing from this left side going over. So if I'm over here at -4 or whatever, I have this value here. If I go to -3, then I'm at 0. -2, then I'm at whatever. -1, I'm at whatever. But as soon as I go to the next value, it's increasing again. So my decreasing stops here. So it's actually coming from the right, from the left. So that's going to be -infinity to -1, or x is less than -1. Okay, so you should have a peak or a valley, where it increases or decreases. So this decreases, then it has its vertex, and then it increases. Okay, changing gears is positive versus negative. Positive is just going to be above the x-axis. Okay, so I want to do this in pink. Above the x-axis is going to be here and here. All right, so above the x-axis is going to be those two sections there. Again, look at the x values. So what are the values where it's crossing the x-axis and then it's above and it's below? So it's crossing at -1, 2, 3. This is a -3, and it's crossing at a +1. So these changeover points are at -3 and at +1. So where is it above? Well, it's above everywhere from -3 leftward and 1 rightward. Okay, so I'll go ahead and do interval, I guess. So -infinity to -3, or 1 to infinity. Okay, this is actually going to be an open a parentheses because it's not positive on the x-axis, it's positive above the x-axis. Okay, also just hint, if you have two different sections highlighted, you're going to have two different sections in your answer. So x is less than -3, or x is greater than 1. All right, negative is when it's going to be below the x-axis, because I'm looking for when the y values are negative. Okay, so again, here is my x-axis straight across, and I want anything below that. So that's going to be all these guys down here. All right. Where does it change over from being below and above? Well, that's going to be at -3 and at 1. So -3 and at 1. Okay, I only have one continuous piece here, so I am going to have, I'm sorry I'm moving around a lot, but I am going to have that -3 to 1. And again, it's open because it's not actually negative on the x-axis. It's actually 0, so it's neutral. It's neither positive nor negative. It's neutral. Okay, so it has to be below the x-axis to be negative, and that's between -3 and 1. So -3 is less than x is less than 1. Okay, so that's just the basic. Now we're just going to go ahead and use these things to answer a couple questions. All right, So this was actually a pretty big ticket item on the EOC, but obviously we're not taking the EOC, but it's still important to learn. So we're going to give you a graph, and I just want to know all the values of x if f of x is less than or equal to 0. What does that even mean? Well, we know that f of x means y. And if y is less than or equal to 0, I want y to either be 0 or be a negative. Because if you're less than 0, you're negative, right? So I'm looking for when y is actually equal to 0 or when y is a negative. So going over to my graph, I'm going to go ahead and do it in orange. Where is y equal to 0? Well, that's going to be closed circle here and closed circle here. And then where is y going to be negative? Well, that's going to be anywhere below the x-axis. So it's going to be here and here. All right. On your Canvas quiz, I went ahead and made interval answers, but on the EOC, you would have done a number line. On your homework, you would have done number line. So you're just going to do a number line, and you just literally pick the values where it changes over from negative to positive or positive to negative. You're just going to find those x-intercepts, which in this case are negative 1, 2, 3, 4, 5, 6, 7, 8. So on your number line, you're just literally going to put a negative 8 and a negative 2. All right, and now I want to, maybe I should back away a little bit here. And now I want to ask, where do I shade whatever? Well, it's kind of obvious, hopefully. If I have two separate pieces here, I should have two separate pieces here, but also negative 8, and it's going away from negative 8 that direction. Negative 2, it's going away that direction. And I do want to include that 0 value, so I am going to make it a closed circle and a closed circle, and it's negative 8 to the left and negative 2 and to the right. Okay, and it looks like it mimics it. It has two pieces and their arrows are matching. All right, all values of x if f of x is greater than 0. That just means is y, and greater than 0 means positive. Okay, it's going to be the exact same number line. I'm just going to go ahead and fill that in. Exact same number line. If I were to go do this problem separately, I would also go, oh, well, I don't want to actually equal 0, so I have an open circle. You can't tell it's open, but I would have an open circle there, and it'd be everything above the x-axis. So then I would ask myself, oh, what are the points where it changes over? Well, that's negative 8, negative 2, boom, boom. I have one continuous piece. Everything between negative 8 and negative 2 is positive, but not including, because it's not including 0. I don't want to include 0. So open circle, in between. All right, and just because I couldn't do this easily on your Canvas quiz, it is going to be in interval answers. So this would be x is less than or equal to negative 8, or x is greater than or equal to negative 2. Or you could also do interval, negative infinity to negative 8, bracket, union, bracket, negative 2 to infinity. Sorry about that, out of the window there. Don't forget, infinity always has parentheses, and if it's a closed circle, if it's inclusive, it's going to have that bracket. All right, so down here, it's open, it's not included, so it's going to be negative 8 to negative 2, or x is between negative 8 and a negative 2. All right, looking at our next example, all values of x if f of x is greater than 0. Again, f of x is y. Y greater than 0 means y positive. So I'm asking, where is this graph above the x-axis? So you want to identify any points where it changes over, which there are none. It doesn't cross it. So where is it positive? Well, it's positive everywhere. Every single point is above the x-axis there. So it's everything. So I would draw a number line. I would label any points that were the changeover, that were the x-intercepts, but it doesn't have any. So I'm just going to pick a number. I always just pick 0, but you can pick whatever you want to. And I'll just pick a couple other numbers so it makes sense. And where is this function positive? Well, it's positive literally everywhere. So I'm just going to draw a line straight over the top. Okay? And then again, you could say x element of the real. You could have negative infinity to positive infinity in parentheses. You could write this answer several different ways depending on what options you have. Okay, the next question says all values of x if f of x is less than or equal to 0. Well, f of x is y. Less than or equal to 0 means it's either equal to 0 or it's a negative. Okay, well, look at your graph. Where is this graph below the x-axis? Well, if it's above everywhere, it's obviously below nowhere. So I'm going to take a number line. I'm going to use the exact same numbers. And where is this guy negative? Nada, nothing. So just leave it blank. You could say x is not an element of the reals, no real solution, however the answer makes sense for the context I'm asking it. Okay, so you've seen two variations, a basic graph. This is kind of like a unique case. The last way you would see this is if I didn't give you a graph at all. If I just gave you some function, which is pretty easy, you need to be able to graph this guy, but don't make it crazy. All we care about is the intercepts. We just care about the changeover from positive to negative. So all you really care about here is finding the x-intercepts, which remember is solving for the zeros. So I'm going to go ahead and set this equal to 0. You could do the quadratic formula, complete the square, whatever you want. I'm just going to factor. What multiplies to be 8 and adds to be negative 6? Well, 8 is 4 and 2. I want a negative 6, so negative 4 and negative 2. Does that add? Yep, that works out. So I'm going to get 0 equals x minus 4, x minus 2. That was the x method for factoring. Oh, sorry, 0 equals. Okay, don't forget, this is the zero product property. You just literally set each of these equal to 0. So you get x equals 4 and x equals 2. Cool. Those are my x-intercepts. So just go over on your graph, and you're going to put a dot at 1, 2, and a dot at 3, 4. I really don't care about the graph and how it looks. I just care about where it's above and where it's below. So I just need to know, does this guy curve up or does he curve down? That comes from the a value. Remember the a value, if it's positive, it opens upward. If it's negative, it opens downward. So this guy is a positive, so I know he's going to open upward. I actually know his y-intercept is at 8, but who really cares? I just happen to know that because I like quadratics. But all we need to know is that it does something like this. I just need to know it crosses at 2 and 4, and it's above to the left and to the right, and it's below between those two. All right, then let's go ahead and answer our question. All values of x if f of x is greater than or equal to 0. So when is y equal to 0 or positive? Where does that happen? Well, that happens, it's equal to 0 at the dots, so those are closed there, and then it's going to be above positive, so boom, boom. All right, so on my number line, we already identified our points. We did the math over here as 2 and 4, but we graphed it. So I'm going to put a 2, I'm going to put a 4. All right, I'm sorry I'm moving around so much, but it's okay. All right, so where's it positive? Well, we just highlighted two separate things, but it's going left at 2 and right at 4. So left at 2, right at 4. I did it wrong on purpose because make sure it's equal to 0. Make sure you fill those circles in there. If it's got an equal to there, it should be equal to there. Okay, and that would be negative infinity to 2, bracket, union 4, infinity with a bracket around the 4, okay? And then the opposite, the converse of that is when is it less than 0? So it's just going to be the opposite. I'm still going to have a 2, I'm still going to have a 4. It's not inclusive, so it's going to be open and open. And where is it less than 0? Where is it negative? It's going to be between 2 and 4. So just graph it between 2 and 4. And these guys are always the opposite of each other. So if it's closed over here, it has to be open over here. If it's going left and right, it has to be connected over here. So once you know one answer, you know the other one. All right, hopefully that wasn't too fast. And I miss you guys and hope you guys are doing great. And I'll see you tomorrow. Bye.